So we are live. Okay. I guess.
Hey, yes, we're live.
Hello, Dave. Hello, world. Hello, everyone. I know
Hi,
we got.
everyone.
I know we got at least one person from India, and we and a few people from here and there. So welcome, everyone. And Dave and I will kick off by introducing ourselves. So, Dave, why don't you begin?
Yeah, I'm Dave Mariani. I'm the CTO and co-founder of AtScale. And Kirk, well, how about you?
I am Kirk Borne. My friends call me Captain Kirk. People who don't know me call me Jason Bourne. So,
I love it.
But right now I'm a chief science officer at DataPrime, an AI startup, and also run my own freelance business called Data Leadership Group. And people said, "Oh, who's in your group?" I said, "Just me. It's a group of services, not people. A group of one."
Great. So Kirk, what brings us together today? I think it looks like we're going to be talking about modern analytics infrastructure and data products and semantic layers, all kinds of fun stuff.
Yeah, I really like the start off. The title of this session has a lot of buzzwords in it, and so maybe the subtitle is demystifying the buzzwords around data architecture, data products, and semantic layer. And I think this is one of the reasons that I've been sort of doing things with you guys, Dave, at AtScale for the past couple of years is something I've been passionate about, and you turned it into a business. So obviously you're passionate about it. So a little bit of jealousy here that you turned this into a business. And so I always like to start with people saying, well, what is semantics? I mean, I taught a graduate course at George Mason University for a number of years, and it was I called it a comprehensive data science course in one semester. And so I basically covered databases and data mining and machine learning and all kinds of different applications in different domains, all in the same class. And I had an entire lecture on Internet of Things and sensor analytics, but also a lecture on semantics. And so I started off with my students. And this was like actually several years ago when I first started this technique with my students. I would ask them at the beginning of the lecture, what would happen if you typed into a web browser, a search engine, the question, how many cows are there in Texas? So type that question, how many cows are there in Texas? Then I asked my students, what do you think you would see in the search results of that search engine? And they pondered a little bit, but they are clever students, and they realized, what you would get would be web pages that had those words on it. Okay. You wouldn't have an answer to your question. You would just find web pages that had those words because the search engines at that time were nothing more than just keyword search. Well, search engines now have a lot more semantics built in and by that we mean it understands your question. It understands the words. It understands that there is a question there, and it ought to return an answer to the question, not just pages that have the words cow and Texas and so forth. And so what we want to do with our data is enable the same sort of thing for our business users of data. They want to ask a business question and not just find things that have the words of their question. They want to find the answer to the question. And so that's something that's been near and dear to my heart for decades, because I spent 20 years also working on data systems at NASA for space missions. And we were running the data systems for end users. Okay, so we weren't actually what I was doing. I wasn't doing anything with the space mission. We were running the data product delivery system to scientific end users. And so they wanted to find answers to their science questions. They didn't want to just find you type a set of keywords and you don't want to just find the words. You want to find the answer.
Yep.
And so we always sort of envisioned that we would get to this point. And specifically in the science world, but I see now the business world is doing exactly the same thing, which is sort of the story of my career. I sort of migrated from being an astrophysicist to a generic sort of data scientist, because the world is filled with all kinds of cool data and all kinds of cool industries, not just astrophysics.
Kirk, a lot of that you talk about this semantics and the like, and a lot of using knowledge graph or talking about knowledge graphs, and sometimes using them interchangeably, which I'm not so sure I agree with. But what does a knowledge graph mean to you, and where does it fit vis-a-vis semantics, a semantic layer, for example?
Yeah, I think I've been guilty of that myself. So when I taught that course that I was just mentioning, I brought out in the whole concept of ontologies, which are basically expressions of relationships between things. Okay, like Dave is a person. Dave works at AtScale. AtScale is a company, and and so forth. So you can create these entity relationship statements, and they're basically noun, verb, noun triples, as they're called, right? And so you have a noun, Dave, a verb is a, and then another noun, person, or and so you can build a graph there because each noun has an edge that is a connection to other nouns through all the different verb combinations. So that's a graph, right? And so you can it's like aspirin is a drug. Drugs treat diseases. Headache is a disease. Aspirin treats headache. Okay, so you can actually find a path through the graph that leads you to knowledge and insight because you follow the edges that aren't necessarily connected. So a lot of times we talk about that as a knowledge graph. The ontology is the actual sort of the instantiation of what are the entities and what are the relationships that you are permitted to use. So a medical ontology certainly has a different set of relationships, like is a treatment for, is a symptom of, is a cure for that. So those are obviously that's specific to a medical ontology. Right. And so knowledge graphs then bring semantic meaning to data when you start seeing these connections and relationships and sort of the context in which a fact lives. Okay, so that's really the key thing. There's a fact, and that fact lives within a context, and those entities and relationships sort of put it in context. So in business, it's similar, though you don't need to have the ontology when you're talking about a semantic. You don't necessarily have to build an ontology, but what you're building is basically words that have meaning within a business context. Okay, so for example, your database may have a column called customer. It might have a column called cust. It might have a column called customer name. Okay, those are all the same thing, right? Revenue, sales, profit. I mean, so yeah, some of those words have different meaning, obviously, in an accountant's mind, but to an end user at the business, they may be just sales. Okay, so the semantics layer gives you sort of that unification of this terminology, and so in some way, you can think of your brain does the ontology, right? Sales is revenue. Revenue is money inputted to the business. Okay, that kind of. So your brain already does that thing, and that's the whole point of semantics, is that let's try to get our databases from just being rows and columns of things to actual insights delivery.
It's like, and for I hear a lot of people, you can query a knowledge graph. In other words, give me all the types of people there are. So you can query the knowledge graph, which is basically all those connections to those entities and those relationships. But that's different than a semantic query. So in AtScale, we have a knowledge graph that powers our query optimizer. Because it's a dimensional model, and dimensions are entities and have relationships. And that's what allows us to sort of translate a question of, well, how much revenue did I earn in North America, between 2019 and 2022? That's a different kind of question because you're asking questions of the data. And yeah, we'll go ahead and use that knowledge graph to be able to sort of say, okay, well, what they're really asking for is that time dimension, which is connected to this fact table that has revenue in it, et cetera. And then we'll generate a SQL query from that. But that's a query on data, right? It's a query on actual data as opposed to querying the graph. And I don't know if I can explain that really. You did a really nice job, but they're very different things. No, I mean, in terms of querying the knowledge graph versus querying a database.
Yeah, they really are different things. But I really like the way you described that optimizing queries and databases has been around for decades. When I first learned databases 40 years ago at NASA, showing my age here. Well, actually 37 years ago. Let's not push it here. Okay. When I first learned about databases, and I would write some very inefficient queries. I mean, I would write 8-way joins. So if anybody knows what that is, it can bring the database to its knees. It can take an hour to answer a very simple question. And so I would talk to the database people, and they would say, "Oh, we're optimizing the queries in different ways, and use this particular data model, blah blah blah." I mean, they started giving me this lecture about how to queries needed to be optimized, and I think sort of behind the scenes there is essentially what you just described. I mean, maybe not as much back then as you're doing now, but there certainly was some kind of a knowledge model of the query process in order to optimize that query. So it wasn't visible to the end user that there was some kind of graph like that in the background. Now, clearly you have more of a graph now than I imagine they had 30 years ago, but so a knowledge graph then becomes sort of like making that that structure visible to the end user, actually, or another way to say, maybe usable by the end user. So it's not just it's optimizing a query, it's actually the thing you're querying.
That's right, and there's value in that as well. And I think that's where, at least sometimes when I talk to customers and prospects, they get a little bit confused, because a knowledge graph can be a standalone product that adds a lot of value, because it's going to crawl your data and kind of come up with these ontologies or these relationships by inference and the like. But a knowledge graph also could be used in other products to actually do the job, and that's kind of where that's the use case for us. And AtScale is like, we use a knowledge graph to actually serve as a query planner, to be actually query a database. But we don't expose the knowledge graph directly to a user. It's sort of invisible behind the scenes.
Yeah, I guess in some sense it's the difference between a product and a service, right? I mean, because it's, in a sense, what you're describing is a technology or a service that's optimizing queries, and that yet other people want to acquire, like a regular business knowledge base. When people talk about a knowledge base, for example, find me the people in your organization who are experts in this or that. So that's now the product. I mean, that knowledge graph is the product that someone is using to achieve something. So I think it's sort of fluid in the sense that these aren't like either ors. I mean, there's sort of some crossover between using it as an infrastructure layer as opposed to as a user layer. And I think that's what makes it sort of interesting now, is that I guess I would say that it benefits everybody if we sort of like blur that distinction instead of are you one of these or are you one of those? Well, we are just using this technology called Semantic to enable, usability and discoverability of these crazy large data stores that we have.
Kirk, I think of like AI kind of in the same way. Today it's like we always think about it as a sort of one-off. There's a data scientist who's making predictions, but really it's like that could be a service that's in another product, like a BI tool, for example, which is going to do some simple regression to take historical sales and create something called predicted sales. I mean, you can also operationalize that activity to also be a service, as you called it. I really like how you kind of made the distinction between a product and a service. And there's a lot of things like that, and I think that's another sort of thing that my prediction is that AI will be truly democratized by being embedded in other products where users don't even know that they're using AI. It's just something they're doing.
Yeah, I think I noticed you use the word products a lot in your comments there, and I think that's the thing that's really exciting me these days about sort of the evolution of data analytics and business in the semantic layer, enabling that, which is focusing on the products of what we're doing with our data. So focusing on data products, analytics products, because it's really about those products that basically, I don't know, move your business forward, right? You need the foundation, you need the infrastructure, just like you need this, you need a foundation to build a building, right? But people don't go to your building because you have a cool, underlayment of cement and rebar. I mean, they probably wouldn't come to your building if you didn't have that, but that's not why they come there. Okay, so again, they wouldn't come to your business if you didn't have a really good infrastructure to enable these kind of things. But it's the data products, it's the analytics products, that drive your business forward, that enable both your own internal business users, but your customers as well.
Kirk, what is like, because data products I get confused sometimes too, because it's a very broad term. So what does that mean to you? And, what's an example of a data product versus a service or like you said, like a raw material, like
Yeah.
like cement and rebar.
I got a piece of paper here, which okay. So first I want to start with an analogy, then I'll answer your question, right?
All right.
So I was reading this analogy about, which started off by, this is from Doug Laney, who's written the book on infonomics. He actually was the guy who defined the 3 V's of big data about 20 years ago.
Oh, I didn't know that.
So Doug Laney emphasizes, and I truly appreciate that data is not the new oil, because oil has one use and it's done, right? Data is reusable multiple times, and you can create many outcomes or products, which we'll get to that definition, from the same data. Okay, so it's a reusable, sustainable data source, if you will, of value creation in a business. And so he used the analogy of wheat. Okay, so raw wheat. Okay, so I wrote this down so I wouldn't forget it. Think of data as wheat. All right, but unless you're a farmer, you're not selling wheat to customers, right? So from data, you can go from that raw wheat to flour, and from flour you can create bread, or you can create artisan breads, or then you can create all kinds of interesting sandwiches and have a sandwich shop, right? So you're not selling wheat to people, you're selling sandwiches to people, or you can make cakes or even magnificent pastries. Okay, so you can end up on the Great British Baking Show. I mean, there's a progression there going from the raw product to something that is a business, is a business thing that you're selling, right? So a business product, let's just say it that way. So a data product, something that comes from data, it's a refinement of your data into something that's usable, reusable, sellable, provides insight and value to your business. So I think when I say data products, I like to think of all the kinds of things that come out of it. For example, as a visualization is a data product, a dashboard is a data product, but a data product can also be a machine learning model. For example, a predictive model of customer sales, right? So if people can invoke that model, so how do they invoke it? Maybe through an API. So an API might be a data product, or an app on your phone that uses data. That's a data product because it's using data to produce some kind of value for the end user. So data product are all those things that you refine that become, sort of the end result of doing something with data that turns it into value. And but there's another example which I would like. I
love the example of wheat, and I think of sandwich, right? Okay, yeah, you're right. Sandwich is like it's made of wheat, just like you could have a semantic layer that's an ingredient into a visualization, but it's not the semantic layer that's a data product. It's really the visualization that sort of puts that all together in one package. I like that.
And there's another data product that's really come into a lot of discussion in the past year or so, and that's the feature store. Okay, so the feature store to me is like sort of the culmination, in some sense, and my own limited way of thinking of semantic layer. It's that place where you find sort of the common, sort of refined data products, that the different users of the business need, the business users, the decision makers, the data scientists, the data engineers. These people, these are the places you go for the refined data products to do whatever your job is in the business. So what enables this sort of data literacy and data fluency across the whole organization. It's not just reserved for the data scientists sitting over there in the corner. Everyone should be able to do insights discovery, and then value creation and innovation from data. So what is a feature store? Well, I wanted to show you this example. I got this little slide here. So I think we can bring up this slide. Maybe.
I think you just have to click it on the down below there, Kirk. If you click the tile, there you go.
Oh, there it is.
Yep.
I think our host here, helper here, Robert in the background has brought this screen on. So what is this? I always use this as sort of my entree into my data literacy talks, but it emphasizes the point of a feature store. So let's start with just the sign itself. Okay, so this is a sign for a little town somewhere in South America. I can't remember which country it's in. And you look at this, and it has the population, the feet above sea level, and the year the town was established. All relevant information about this town, and then someone added these.
I love that.
I'm glad you're laughing, because sometimes people they don't know whether to laugh or not, because I show this slide, sometimes it's to a general public audience, right? When I'm sort of like introducing data literacy in a general public audience, they're certainly, they come in there thinking data is a 4-letter word, so they're not really sure where I'm going with this, but most of the data scientists, data savvy people in the room like you just laughed, because wait a second, you can't add those 3 numbers. that makes no sense. I mean, they're 3 completely different things, right? I mean, one of them is a number of people, one of them is a measurement above sea level. So it's
one of them is time.
It's a length, and one of them
Yeah.
is not even time. It's a time stamp, which is the year 1951, right?
Right.
So what is that? So anyway, so I start with this, and then I tell the story of how there's all these different lessons you learn about data from this. First of all, to recognize, the very first lesson is awareness. That is, all these things are data. Okay, so for some people, they think data is a 4-letter word, right? Oh, it's that thing that XYZ company is using to steal my identity. Well, no, this is data. This is information about a town that you might want to know. What's the population? What's its elevation? When was it? These are useful pieces of information. But by themselves, they're just information. There's not a lot of insight here. And so there's not really a data product here, except for these adding those 3 numbers, which is a pretty useless data product, because it doesn't really mean anything to add those numbers. Because what if your elevation above sea level was in meters? That's a different number, right? Okay, so now all of a sudden you got a different number there, but it's still the same town. So it's not a very descriptive data product just to add those 3 numbers. Well, let's think about it another way. What if we take these numbers and do a little magic with them? Okay, so for example, something that data scientists do is they normalize it. That they put everything on the same scale. Instead of people and feet and the year, let's put them on a 0 to 1 scale. Okay, so you find out, sort of like, you look at all the towns in this country, and you figure out what the minimum and the maximum population is, and you just normalize that by just dividing by the range, and subtracting the minimum. That's a mathematical thing. But basically, you put everything on a 0 to 1 scale. So now you can see the most populous to the least populous instantly on a 0 to 1. Do the same thing with the elevation above sea level. Find the min and the max, divide by that range, subtract the minimum. So now everything is on a 0 to 1 scale. So now you have some uniform way of seeing where that town is relative to all the other towns in that data element, elevation. And then the third one, year established. Well, we can do a little conversion here. Turn that into, how old is the town? Okay, so the year itself may not be necessarily a meaningful thing, but how old is it? Okay, so in this case, it's 71-year-old town. Okay, so now you can take all the towns in the country on a 0 to 1 scale, the youngest to the oldest. Okay, and so you can see where that town lands in that element. So now you have 3 numbers which are independent of the unit. Feet above sea level, year established. It's all 0 to 1 scale. So now you can say, okay, find me all towns like this one. So how would you do that? Well, we create a feature vector, right? So there's 3 elements here, all 0 to 1 scale. You can find other towns that have a similar feature vector. Find the ones that are most similar. Find the ones that are least similar. Build clusters around that. So it's almost like customer segments. Okay, so your customer segments might be similar kind of thing. How long have we had this customer? How much money do they spend in a year? What fraction of the money do they spend on books? What fraction do they spend on electronics? What fraction do they spend on entertainment? Okay, so now you have customer personas. So you've built a feature vector that anyone in the business can query and understand it. Okay, and so this is a data product, this feature vector, that anyone can use, and you could. And what do you do with this feature vector? You put it in a feature store. Or if you don't build the vector, you just put those numbers in there: population, feet above sea level, age of the town. But now you can start adding features, like what fraction of the businesses in this town are manufacturing, what fraction are agriculture related, what fraction are technology related. So now you can build all these different type of ways of describing towns, and start doing all kinds of analytics to find similar towns, different towns, groups of towns. So if you're selling some particular product that's meaningful to small towns, then this is where you would go. Or to towns that are high above sea level, because maybe they have skiing there in the winter, and so you want to sell certain products that way. Okay, so there's all kinds of things you can do once you have this information in a computable, digestible, usable way by all the end users in the business. And that's made possible by the feature store, which is made possible by the semantic layer because it's pulling different data, these different numbers, perhaps, again, not these numbers, but the numbers about your customers and about your business and about your market from many different data sources. And so it's now homogenizing all those different sources into a common language or a common feature descriptor. So now it becomes usable to your business analysts, your data scientists, your machine learning people, your decision makers, even your end users. And hey, if you build a nice feature store, you can even sell it as a product, that data product to other businesses. You can do a B2B play by selling it as third-party data to other businesses. So now you got all these revenue streams from your feature store. So that's a data product. It's that thing that you can actually make money off of. It's a product of your business. And so the phrase I like to tell people is the wrong mindset is to think of data as a byproduct of your business. True for many, many years. People say there's data exhaust, right? Okay, just the number of visits and clicks on my website is data exhaustion. What are people searching on my website? That's like data exhaust. What they're really those people are looking to buy a product and they bought this product from me. Yeah, but look at the data exhaust. What pages did they visit? What search terms did they use? That's additional information besides just the thing that they bought. I mean, that thing that they bought is just one data point in a long journey, a long chain of data. Okay, so think of the data not as a byproduct of your business, but as the actual business you have. The data product is the thing that's earning you revenue. So anyway, I just want to tell that story and see what your reaction to that was.
I think that's a great. I love analogies. That's how I learn, so that's a great one. So you did a great job at defining the data product, and I think everybody that was a great explanation. So let's talk about a little bit about who creates data products. There's a lot of talk about data mesh and different ways of decentralizing data product creation. But what's your thoughts, Kirk, on just about the people part of this, not just the technology, the ingredients, and the ultimate outcome, but how you get there?
Oh, I'm a big proponent of the who there. I'm glad you asked that question because I'm a big believer in data for all, data literacy for all, building a data literate work culture that it's not just the data scientists who should know this stuff. So yeah, the data scientists and machine learning engineers, they all have their role, obviously, but everyone should be able to use data in their business, right? And so a data product is something that any user in the business, any business person, and the analyst, the decision maker, the front office receptionist, even I had that conversation with someone once. Even that front office receptionist is collecting information about who comes through the door, who are they asking for, when do they come. I mean, there's sort of like foot traffic data. Everything is data. That's my data awareness thing. First step is just realizing everything is data, and so everyone can contribute because then that person could say, well, this is the data or information I need to do my job. Okay, so it could be anyone in the organization, and so if they can identify what is that sort of product from the refined product from the raw data that enables them to do their job better, then they should be able to have a conduit, a communication channel back to the data team to include that within that decentralized data mesh, if you want to call it that. So that maybe the foot traffic data is going to be important for the front office receptionist, and maybe in terms of other aspects of the business where you need to have a certain number of people available certain times of the day or days of the week because of foot traffic or customer calls or customer purchases. I mean, you may have a product that sells online and people will tend to buy it when they're off work. Okay, so it might be an entertainment product. Well, if you're in most jobs that I've had in my life working at government agencies, you don't do online shopping for entertainment while you're using the government computer. You do that when you get home. You do that when you get home. Okay, so there's going to be a sudden uptick in terms of people trying to use your e-commerce store in the evening. Probably in general, that's probably in general true. Okay, so you want to have people on call if that's your business, running an e-commerce store, to have more service representatives available in evening hours than otherwise. And so again, all these things are that information. How many users are on the e-commerce site at different times of day of week. That information now comes from data. And from that you get insight, and from that insight you can build an actionable plan, which is if you were running such a business, you would have to have like a schedule of when you have people on duty. So the worker scheduling program, how your workforce deployment model needs to use that information. Okay, and so now that workforce data model deployment model is in a sense a data product.
Yep.
So let me tell you a quick story that came out of COVID. Okay, this was one of those cases of COVID totally screwing up our models. Okay, so we all know how COVID screwed up all kinds of models, like purchase patterns, network usage in buildings, right? Because everyone was working from home now instead of in their office building. So network users, purchase patterns, all kinds of things changed dramatically during COVID. But one of the things that surprised me was a story I heard about a company in India, actually. And so this company in India was sort of I would just call it like an Uber Eats, if I can use that word here, but it was the kind of, they were like the intermediary that connected drivers and customers and restaurants who had food. Okay, so people would order their food online, all right, and a driver would pick it up at that whatever restaurant it was and deliver it to your house. And so this particular business had a certain workforce model where throughout the entire week they would know how to distribute their 80 workers. They had 80 workers in total, and they would have a work schedule. And certain hours of the day, days of the week, they would have more people on duty than other times of the week. Well, when COVID happened, everyone was suddenly working from home and ordering food all over the place. So their predictive model of workforce deployment broke completely. How bad did it break? Well, they told us. They went from a company that employed total of 80 employees for their entire 24/7 scheduling they had to do each week, to the point where they were hiring 100 new call service representatives daily. 100 new employees every day.
That's crazy.
From an entire company of 80 people, they were hiring 100 new people every single day to respond to the COVID thing. And so whatever predictive model they had for workforce deployment was just completely broken. Okay, so that workforce model was a data product, and so they had to take the data, the new data about when
retrain that product,
and
right?
retrain that product. Okay, so the workforce model that they had was a data product, which was a reusable data product over many years. Okay, they didn't have to. I mean, I'm sure they refined it and tweaked it and stuff like that, but it was pretty much a workable model. Well, it was completely not workable. And so we talk about concept drift and data drift and things like that, and ML ops, where you have sort of the AI is watching the model, so to speak, for model failure or model drift, that kind of thing. And so to get that model right, you needed all this extra additional insight from new data. But the final thing that the business used was that workforce deployment model, which is their data product.
So that's really a great story and meaningful. So I want to go back to your wheat analogy for a second, though. So if I take your wheat analogy and let's just call it a sandwich that gets built at the end of the day, and that's the data product. Is it the central data team that's responsible for curating the ingredients for the sandwiches, and then it's the business who makes the sandwich? Is that how is? Because I just want to really sort of talk a little bit about how do organizations, how do they separate that labor, the roles and responsibilities? Because I think it's traditionally data teams provided some of that infrastructure, the pipelines and the data warehouses and sort of the infrastructure to allow the business to create the data products. Is that the way things are continuing, or things changing? What's your opinion on who makes the sandwich and who gathers the ingredients?
Yeah, well, I want to expand on your analogy there a little bit. So imagine it's a bakery. All right. So if you're just selling a sandwich, I mean, it's probably a simplified process, right? So in some sense that food delivery thing was simple in some sense, because it was really just one thing. They just needed to deploy a workforce to answer customer calls. And again, they were the customer service center, right? So if your food was cold or was misdelivered or was not delivered, that's who the customer called. Okay, so they had a one product. One thing they did, which is answering service calls, when they needed to have people on duty to answer the service calls, which is what the problem was. The workforce schedule was screwed up. So a shop that sells cakes, cookies, and sandwiches will have different people making those different things and different ingredients. So you need to have people who both understand what do I need. So the people who are ordering the recipe pieces, right? Ordering the flour, ordering the sugar, ordering the jams that are going to go into the the pies, or ordering the condiments that are going to go into the sandwiches. So there's different people who are responsible for identifying what those things are, and those are probably different people from those who are ordering those things, and they're completely different people from, say, the business owners who are looking at the market and saying, hey, there's this new trend that people really want to buy this kind of thing. All right. I mean, people are really shifting their interests, from just sandwiches, to artisan donuts or something. I don't know. I mean, whatever it is. I mean, so you got the decision maker overseeing all this. And so all these people need to have some kind of access to what's the data. So even the person who's making the sandwich, customer facing at the cash register, so to speak, person orders this or that kind of sandwich, and they need to know, well, we're out of okay, you want a pastrami sandwich, well, we're out of pastrami today. Okay.
Yeah.
I mean, so even that person needs to have some insight. So again, let's not talk about just pastry shops here. So in the data world, in the business world, I mean, there's data sources from everywhere, right? I mean, you got customer data, you got product data, you got supply data, you got demand.
All the raw ingredients. Yeah.
You got the market data. You got if you have an e-commerce store, you certainly have click data and abandoned shop cart data. I mean, you got all kinds of data. So all this stuff has to be understood and at the high level by the decision makers, so they need a view of the data that doesn't get too much into the noise, into the bits and bytes. But there are some people who are going to need to get into the bits and the bytes. Okay, so if you have a one source of truth for all these people, that's what the semantic layer enables. It's sort of like the Rosetta Stone, right? I mean, I come in with this kind of business question, and a data scientist comes in with this kind of predictive modeling question, and the business there's the decision maker, then there's the business user, who might be the person who's ordering the ingredients for whatever their company's building. That person has another way of asking the question. That is, what is in our inventory? What is the delivery time of if I need to replenish the inventory in our warehouse? I mean, so if we don't have a single source of truth that can answer all those different people's questions, then we're going to get different answers that aren't going to. If I can use the word mesh in a sentence beside data mesh, their answers aren't going to mesh. Right? You're going to get a mismatch between what different people are doing in the organization.
Well, I think, and I want to get to there's a question from the audience, from the listeners, but I want to, when I think of like the semantic layer, it's like really that semantic model becomes sort of like, I use the word Rosetta Stone too, because if you think about the guys in finance understand money, people in marketing understand campaigns, the people in sales understand how to get money from people, and they understand their own data sources to the point where they can create their own data products. But if you want to be able to answer a question that crosses those domains, and for example, what's the ROI cost model finance owns for my marketing campaigns? It's the marketing team. Together, you need to sort of put those things together. And so we've been really working on this whole concept of being able to plug and play models like Lego blocks together so that you can sort of, encapsulate the core knowledge of those domain owners, but then have a mechanism to share and connect to create all new data products from smaller data products, if that makes sense.
Yeah.
And so that's really exciting, and I think that's some of the power of data mesh we don't talk enough about, well, how do you share across domains? What is the Rosetta Stone that allows finance teams to share information and their domain knowledge with the marketing team, other than in a semantic model or semantic layer that will allow you to connect those two different domains together to create a whole new data product from that?
And yeah, that's really exactly what it is. It's enabling the right kind of communication across those business units. I mean, another example is data scientists will build predictive models of some of these things I've talked about, and they can put their predictions, which are just data, into a searchable database, right? So so the business owner or the salesperson or the marketing person can query that data what is the prediction of this or that?
Mm-hmm.
The demand for this product or the sales of this thing. Uh, so so people are generating products within their own business unit. Okay, so the
Mm-hmm.
data scientists are producing products which are predictions of things,
Mm-hmm.
and oftentimes they deliver those predictions to the executive team because the
Mm-hmm.
executive decision makers want to know these things. But there's other people in the business who also want to know that, and so if it's searchable and curatable, that is something that's got a sort of a common language, which is the semantic layer gives you. Like someone can call it a prediction, or some people can call it, whatever you want to call it, forecast. I mean, it can be different words, but we can get the same access.
So Kirk, Jeff is asking something along similar on those
Yeah.
lines. He says, should I be staffing a knowledge curator on my data management team? He kind of has a follow up with it's about getting the metadata and so how that all that works. So what's your reaction to Jeff's question there about how should he be staffing? Should he be staffing a knowledge curator in his data team?
I think I think so. I mean, I think obviously for a small business this doesn't make sense, because you're just talking to yourself maybe. But I think for a larger business, if you really want to have a single source of truth for your data, I think that's, curation is number one. I mean, first of all, knowing what you have, where you have it, what it is, maintaining it, and providing lineage, as we call it, versioning, provenance, that is who created it, when they created it, why they created it, who's using it. So that knowledge curator provides a huge amount of value to the organization. So I think that's right. I mean, and he mentions metadata in there, and metadata is just other data about your data, and that's absolutely essential.
Yeah. And you know what? I don't, and I think a data steward in the sort of the definition of a data mesh. A data steward is somebody who is that curator, right? And they have knowledge about their domain, and again, they can then encapsulate that into a model that they can then allow other people who don't understand as well as they do to actually consume and build their own data products using their knowledge that's been encapsulated in that model. So I think it's like it doesn't need to be a single person on a data team would be my answer. You need to give them the business the tools where they can curate their own knowledge graphs and semantic layers based on their knowledge of the business and their knowledge of their data, which is going to be, you can't expect, I would say, like it's easier to teach the business how about data than it is to teach the data team about the business, because you can't just have, you can't have one person that understands every aspect of every business. It's just not humanly possible. So we have to decentralize that somehow, to allow people to collectively, record their know-how and their knowledge of their part of the business, but then share it with others.
Exactly. I agree with that. I maybe I was a little too specific in my answer, that thinking that knowledge curator would be a single person, but I think what you're saying, what I was trying to say was it's a function.
Yes.
And the function, it isn't necessarily a single person. It's just something that happens in an organization, but it's something that has to be done. Okay. Again, it could be spread over teams of people or whatever. I think one of the other things that comes from this is the data quality question comes up when you talk about single source of truth. I mean, okay, so you put everything like you say, customer sales, customer purchases, customer value, revenue from customer. I mean, you have all these different words that are in different databases. How do we? And you say, okay, well, we're going to define it one way, and you put a number in there. Well, how do you know that's the right number? I mean, so I think more eyes on the data enables you to identify when you have quality problems, right? So, so my example goes all the way back again to my early days at NASA. So I came out of graduate school, PhD in astrophysics. What did I know about databases? 30 plus years ago, databases were only in banking and finance world. I mean, now they're everywhere, but I mean, back then you just didn't encounter them in other places. So I didn't know what a database was. I mean, I used data all the time, but I didn't know what a database was. So I started learning SQL, and I started learning all the wonders of doing selects and group bys and all kinds of different kind of queries. It was kind of interesting because I love programming, and it was a new language, SQL. So one of my jobs was to do reporting of things for NASA headquarters. That is how I was working with the Hubble Space Telescope, and I would be sort of like querying the database for how many users how many scientists from different states in the United States were using this telescope. What kind of what kind of science was being done. There were 6 instruments in the telescope. Which instruments were being used? So I was slicing and dicing this data. So one of those queries that came up was how many different scientists from the different states. So I learned how to do a select group by these unique state names, right? So I learned how to do that, and it just gave me the count of the total number of scientists from each state who were using the telescope. And I found out by doing this that there were 93 states in the United States. And I go, what? And of course,
Calif.
Massachusetts was spelled like 10 different ways. I won't even get into Connecticut, how that state even has its name. I don't know. New York, even something as simple as New York, 1 word, 2 word, uppercase, lowercase. I mean, these were all considered different to the database query. All right. Now, so we had a data quality problem. So I discovered a data quality problem. But the reason I even identified it because I knew the right answer. I knew the answer was not 93.
Right.
Okay, so if I was doing something like a marketing campaign and I said, "Hey, I'm giving you," I'm a data scientist, and I go to the marketing office and I say, "Hey, I got the results from your 75 campaigns last year," and they say, "What are you talking about? We only had 30 campaigns." Okay, so the marketing person knows the right answer. I didn't know the right answer. Okay, so what you get when you get this curated knowledge. Or I like to maybe even call it an insights curator. Right? Okay, so if you got some insight from the data, does that make sense to other people in the business?
Yeah. Does it pass the sniff test?
Exactly.
I love that. Yeah.
Exactly. And if I was the data scientist on that team, I would not have known that there were 30 marketing campaigns instead of 75. Right. And similarly, you could think of sort of similar examples across different other cases in business units where other people know. So in my case, I just happened to be a U.S. citizen. Now, for that NASA project, about a quarter of all the scientists on that project were provided by the European Union because the European Space Agency was a funder of the project. And so, maybe some of these people who just came over from Holland or from Austria, maybe they didn't know how many states in the United States. I mean, I don't know how many states or provinces there are in Austria. If someone asked me, I would have no idea. Okay, and so I just happened to know the answer that the answer was wrong. So we're addressing both data quality problem, but also sort of a knowledge curation problem here.
Yes.
And that is who holds the truth, who holds the knowledge about
around geography and location.
Yeah, around in this case,
to me, I would call that a conformed dimension. And then because I would be conformed, so you'd have 50 states, and whatever the raw data was would be conformed to map into those 50 entities.
Well, the funny thing that we actually counted. Just Colombia counted as a separate in that context. It counted as a separate political unit. Puerto Rico similarly. Okay, so there was actually like 52 if you count Virgin Islands. I mean, if you count some of the colony, I mean, so it's not exactly 50 because there's these other units, political units within the United States that count separately. But it certainly wasn't 93. I mean, especially as soon as I looked at the list and again I saw all these different spellings of very common state names. So again, that the issue is if you had the person with the wrong knowledge, they wouldn't recognize the data quality problem. So your single source of truth could be not truth at all. And so I think
this great analogy, Kirk.
So the semantic layer, when you're connecting in this decentralized way, the knowledge and insights and data across the different business units that are using maybe some of the same data, but they're using different data sources maybe to answer the same question. Well, why are we getting 2 different answers? Well, someone ought to be able to help trace why we're getting 2 different answers.
Yeah, and if you use those conformed dimensions as sort of the connective tissue between these different sort of models, then that if I do look at my ROI by campaign by state, I know that that the way we're thinking about state or location in finance is the same way we're thinking about state or location in marketing, which is what enables me then to do ROI by location. So without that sort of common language, you really can't do that, and you can't really share data products because they have there's no way to connect them.
Yeah, and then we go back to this whole concept of a feature store. What if for some reason the location data that mattered was the time zone you're in, right? Okay, so for some marketing campaigns, that might be particularly relevant, especially if there is some sort of time-sensitive thing related to what you're doing. And so maybe in the marketing database, we're working with time zones, right? Whereas in some other database, for example, in the shipping department, they don't care about time zones. They care about your zip code, which is okay. So they have zip codes, and then some other place they care about the state you're. So all these things are referencing the same geographic information, just in completely different ways. And so if you can homogenize that and create this feature vector that basically says I can go here and find out the one source of truth about where this customer is, whether I'm talking about time zone dimension, zip code dimension, or state name dimension, or even latitude and longitude for that matter, because you might have got that off the GPS on their phone because they called in, they used their mobile app to buy the product, and so you know exactly where they were, right? So, I mean, they took a picture of the defect of the product, right, and the picture contains GPS location embedded in the metadata of the picture. So yeah, so all these different things are referring to that same conform dimension. I really like you brought that up. I know we're nearly close to time, but
I know, yeah. So we are. We could go talking for days here. I could talk to you for days, but we should probably wrap it up. So anything you think that the listeners out there might benefit from that we haven't covered?
I'm just scanning through the questions here and wondering here, but anyway, I think we've covered quite a bit here. But I think ground. But going back, I just wanted to make one more point. You asked the who question a while ago about who does this, and I heard this talk from a president of an airlines in Europe. So I don't know if anyone ever heard of Transavia Airlines, but Transavia is like a low-cost airline in Europe based in Holland, and it's sort of like Southwest Airlines in the United States, the low-cost airline alternative. And the president of that owner of that company said to his business. It was basically a data democratization statement. He said, if you see something in the data, say something. Okay, so everyone has the power to say something. So again, if some person whose job is not to maintain the database, if they see that it says 93 states and there should be 50 or whatever it is, if they see that there's an issue there, they should say something. And so giving people access not just to the raw data, but to the insights that we're getting from the data. Okay, I get it, in the appropriate way. Don't give access to someone who should not have access. I'm not saying just open up the gates for anyone to look at things they shouldn't be looking at. But if anyone has the proper authority and need to know in their business job to look at data, and if they see something, they should be empowered and enabled and expected to say something when they see something, and not just quality problems, but even insights. Hey, did you notice that our customers are buying this thing when they buy that other thing? Oh, gee, we didn't see that before. Okay, so don't just assume people know, right? I mean, that's the whole point. I mean, if you see something, say something. And it's sort of like the signs you see in the New York subway system, right? For completely different reasons. But it's the same thing. It's really the same thing because humans, we have an amazing cognitive capacity to see anomalies, to see patterns. I mean, that's what we're good at. I mean, that's how we got to the top of the food chain and the survival of the fittest and all that, is because we had this incredible cognitive ability to see and detect and recognize patterns and anomalies and things in our environment. So take advantage of that, because that's a natural human thing. So anyone in your business, I don't care who it is in your business, anyone has that cognitive capability because they're born that way. Okay, so why waste it?
And Kirk, it's like couldn't agree with you more. It's like I always just say, like, I just think we've taken a wrong turn down data and analytics. We've made it so we made the realm of the data engineer, to be able to work out these really fancy queries and understand schemas and cloud data warehouses and stuff. I just think that's wrong. That everybody should be able to use data to make a decision, and that means sort of taking that data to the tools and the things where they live, and it needs to be where they live. And so that's why that's why I started the company for AtScale and the semantic layer is like everybody should be able to use data, not just the experts.
Yeah. So, well, I know you and I have actually been on numerous webinars together. I hope someday we can share a drink, because you just described my career journey. I mean, I spent 20 years at NASA as a research astrophysicist, PhD in astrophysics, working on data systems for space missions. And about 20 or so years ago, I realized that data was exploding, not just in the sciences and astrophysics particularly, but in business and government and healthcare, everywhere. And so I actually left my 20-year career at NASA and went to the university, and we actually created the world's first data science undergraduate degree program about 16 years ago. And the whole vision I had by leaving NASA and going there was to create this program to teach everyone about data. That was always my goal. I said my ultimate goal was I want to teach it to kindergartners. And again, when people laugh at me when I said that, but I'm saying I don't mean teaching machine learning algorithms. I'm talking about pattern recognition. Children can cluster things by color, by shape, by size, even by function. So we already do this. So make it part of the learning process. These concepts of classification, clustering, learning from data, learning from patterns, pattern detection, pattern recognition, anomaly detection, and by the time these young people are ready for the workforce, they've already got the raw skills you need, right? And yeah, you can teach them the business. You can teach them the business, you can teach them things, but if they don't have that innate aptitude, or another way to say it is they already are born with this aptitude, but sometimes the school system doesn't encourage that kind of curiosity and experimentation. You got to follow the work plan in your book. Don't deviate.
And you have to get a job as a data engineer or data scientist to be worthy of using data, which is that's just not right. Everybody
I'm so glad you said what you said because you described my career journey. I mean, I didn't start a business, but I changed my whole career path from what I wanted to be as a 9-year-old kid. I wanted to be an astronomer, and I became an astrophysicist at NASA for 20 years. But I gave that up because I said there's something far more powerful and important here.
I love it, Kirk.
Understanding the universe is pretty big and powerful, but I think this was my life's calling all along. I think.
I love it. We came at it from different ways, but I think we have the same passion of data for everyone.
Well, we converged into that semantic layer, and our conformed dimensions came together.
There we go. Hey,
anyway.
Kirk, this has been.
You saw what I did there, right?
I love what you did there. Thanks so much for hanging out, and this has been a terrific chat. I hope everybody liked it who's listening. And Kirk, we will have to have that drink together. So looking forward to an in-person conference, which are happening again finally. Yeah, maybe we could do that.
I think I received an invitation recently. It just happened to have a conflict. You had some kind of event in DC, I think.
Yeah.
Was that a ping pong tournament or something?
It was a ping pong tournament. Darn.
You have to catch me again another time.
We'll catch you again. Thanks, Kirk. You're the best. And thanks everybody for listening to AtScale's live session. Thanks, everybody.